the examples and the lesson content. All right. So first problem here says log base 2 of 32 equals x. Log base 2 of 32 equals x. So our goal is to write 32 as 2 to some power. 2 to some power. Can you think of what power that would be? If you recall, 2 to the 1 is 2, 2 squared is 4. What would get you to 32? Do you remember?
No, I don't.
Let's keep going here. What's 2 to the power of 3? You're doubling.
It would be 8.
And then 2 to the power of 4?
16?
Okay. And then 2 to the power of 5 is?
32.
Good. So we know that 32, the 32 right here can be written as 2 to the power of 5, log base 2 of 2 to the power of 5. What can we do with this exponent of 5? What was law 3 from the other day? Do you remember?
No, because if I have to look back on the lesson, it's gonna take 3 million years for me to load. So I don't remember it off the top of my head. I'm sorry. I think it would be like maybe law 3 was like log base 2 to the power of 5 equals I don't know.
That's okay. I'm going to go find it, put it in the notes here. That way you got it in case you want to write it down again. Give me just a moment to get back to that, where it is. So let's see here. Exponent graphing, laws of logarithms. There are only 3, so it wasn't like an impossibility to remember it. All right,
Yeah.
so here we go. It's law 3 here. Law 3, and notice that kind of on the left is what you have, and on the right is the difference. Where does the A go?
The A goes to the other side, to the exponent.
It goes in front, so it comes out in front here. 5 times log base 2 of 2. So in your problem, A is 5. So that exponent becomes the number in front, the coefficient. Is that clear?
Yes.
Okay, so this 5 log base 2 of 2. Log base 2 of 2 is 1. So this becomes 5 times 1, or 5.
Okay.
That does it for that problem. That's the answer. So x is on the right. We had to just basically simplify the left. You can put equals x here.
Okay.
All right, on to number 6. Number 6 is more complicated. This is number 6 here. So unlike the previous problem, the variables are inside the logarithms. It's not on the right here, and that was really nice. So we got to go back and, excuse me, we have to go back and we have to look for the law which allows you to combine a sum. So here is that law. This is law number 1. You don't need to know that it's law 1. But do you see where this plus is right here, right in the middle?
Yes.
So what the law says, what it means is that you can take what's inside parentheses of each of the logs, that's your m and your n, and then you multiply them together. That's your product. So that everything that I'm circling is this right here on the right, and it becomes log base 2 x minus 4 times x, and that's all inside the logarithm. And the words we use is that a sum becomes a product, sum to product. You'll see that again in pre-calc trig, sum to product. Okay, do you remember how to rewrite a logarithm, getting rid of the log? We did this the other day a couple of times.
Don't we make it like have an exponent or something?
Yeah, pretty good. So let me go ahead and draw it here. You're gonna use the base of 2 on both sides. So now this whole logarithm is the exponent and this 5 is now the exponent. So on the
Okay.
left here, it becomes just x minus 4 times x. On the right, it's 2 to the 5th power. So this base to an exponent, undoes the log. On the right, you get 2 to the 5th. Could you tell me what 2 to the 5th is?
32.
32, very good. So on the right, we can also distribute this x into both. So this is x squared minus 4x equals 32.
Okay.
What kind of equation do we have now? What name would you give to this?
Isn't it a
This power of 2 is the big indicator of what it is.
I was about to say perfect squares, but
But more
let's
general
see.
than that, What's a degree 2 polynomial always called?
Quadratic?
Quadratic, good, yeah. So to solve a quadratic, the most basic thing you can do is move everything to one side. So it's x squared minus 4x minus 32 equals 0. All right, to solve this, you need to find two numbers that multiply to minus 32, negative 32, but then they have to add to positive 4. They multiply to minus 32, but add to positive 4.
Oh, that would be multiply to -2, but add to +4. Well, that would be like, hold on. I was thinking of 4 and 8,
There's 4
but
and 8, yeah. So one
okay,
has to be positive and one has to be negative.
perfect.
So which one is it? Which one has to be positive, which has to be negative? Remember, your goal is to add to positive 4 because it doesn't matter which one you negate to get to negative 32. They both work, but only one of them will add to positive 4.
Got it. Okay, so
So which one do we choose? And then do you remember what to write here? What do we put in
it would be
parentheses?
-4 and +8
Good.
because we want the 4 to be positive. When you multiply a negative and a positive, it's still going to be a negative. So yeah.
All right, perfect. Now, from here, you have to set each of these equal to 0.
Okay. X equals 4 and -8.
Got it.
Yay.
So now we do have to do a little bit more here because if you recall, we have to check our answers. We can't just say, oh, those are our answers. We're all good. We have to go back to the original. All right. So going back to the original means I get to the page with the original so I can find it here. Here it is. I have too many windows open. So it's not that it's a problem because it's negative here. The issue is when you put it back in, it is the issue. It's like the positive ones are usually fine. What is the issue with log base 2 of -8?
Um, I don't know. Is it because it's negative? That's the issue.
Well, it's not that the value is negative, it's when you put it into a logarithm that it's an issue, because the domain of logarithm says it's only from 0 to infinity.
Okay,
And so the value of negative 8 is outside of that window.
got it.
So that one is excluded or extraneous. So that you generally show that and you write the word extraneous.
So the answer is just x equals 4.
Yes. But we should check it, right? We shouldn't just say, oh, it's good because it's positive.
Yeah,
And you're like, what do you mean by that? Well, let's take a look. Log base 2, 4 minus 4, which is log base 2 of 0. Is that in the domain? Is 0 included when there's a parenthesis here?
yes.
Parenthesis means everything up to, but not including that. It's like getting right to the water's edge, but never really dipping your toe in the water. So
Yeah.
this value is not included. So this one is also extraneous.
So no solution.
No solution. All right, good job. I'm sure it's frustrating. You do all that work and then you, it's like, nope, no solution.
You're like, come on, man.
Yep, exactly. All right, so part C here, these are calculator problems. I know you're kind of limited with your, maybe what you got there. Do you have a calculator or just, you're just on, is your computer maybe able to access that Desmos Scientific?
Let me see. Yeah, it works. So I can use
Oh,
my computer.
fantastic, fantastic. Okay, because the really the issue here isn't actually solving it; it's using the calculator. It's like how to do that. So, to undo ln, you use e, and to undo e, you use ln. And the reason is that these are inverses of each other. So we kind of did this the other day. It's e to the natural log of x equals e to the 4. It's like that earlier problem where we used, if you want to look up here, we used a 2 because it's log base 2. In this problem, ln is really base e, so we use base e to undo ln. So x equals e to the 4. E to the natural log of x becomes x, and the natural log of e to the x becomes x. And that's the whole point here, is that they undo each other.
Yeah.
So you have to go to your calculator and it says significant digits. So that means 3 digits that you see, not 3 decimal places, 3 digits.
So it'd be 54.5.
Good. I like it. Okay, you ready to look at number 8?
Yeah.
All right, so very, very similar to the previous problem, except it's not ln, it's log base 2. Log base 2. We
Woo,
kind of already,
logs.
yes, logs. It's just like that earlier problem. You use a 2 here and a 2 here as the base because the you have to undo this base of 2. So whatever this is, you put down here as the base. Okay, so the left side becomes just 2x. The right is 2 to the power of 5.23. Okay. Is that clear? This 2 undoes that log base 2.
Yes.
At least like that you can see that it where the 2x is coming from. Maybe.
Yeah, I got it.
Okay. Now you're undoing this multiplication by 2 dividing by 2 right here. So x equals 2 to the 5.23 all divided by 2. So in terms of how you do this, make sure you do this first and then divide by 2. The Desmos Scientific calculator will do everything for you if you type it in, the way that you see here. So go ahead and try that, please. I'm going to do the same, and we'll just make sure we're on the same page with our numbers here.
That would be 18 points. Do you want 3 digits or do you want the whole thing?
It says 3 digits again. So for 3 digits, you see rounded though, like that's
So
7.
18.8 basically.
Yes, you got it.
Okay.
The previous one is not 54.5 though. I guess I wasn't paying attention. It's 0.6 rounds. That third one rounds up.
All right.
Small thing. I assume your instructor would ding you for that and say, "Oh, you got to redo it." We don't want to redo it over one decimal
Yeah.
place.
Yeah, that'd
All
be
right.
really dumb.
Yeah. All right. So number 9 is very much like number 7. Very, very much like number 7. This is number 9. So how did we undo ln in number 7?
We did E.
E. So it's e to the natural log of 3.1 x equals e to the 2.31. What does the e do to the ln here?
Did you say what does E do to the ln?
Yes. How do we proceed from here? Like what
Um,
happened in number 7? What was the next line? Did we have an e and an ln on the left side?
no, we had like a E with the exponent.
Right. So so in this case, it just drops out. It just becomes 3.1x equals e to the 2.31. And then you divide by 3.1. So you got to go to your calculator again, e to the 2.31 over 3.1, like that. Very, very heavy on the calculator here.
It's okay. I'm just glad my calculator works. 3.1.
So
Okay.
again, three significant figures. So make sure when you get that third one, you round it appropriately. This is another rounding situation.
Okay. It would be 3.25.
Yes. Good.
Whoa.
All right. So we're up to the apply your knowledge here. And I'll have you look this over. I got to go look at example 12 just to confirm that we're going to do this the way we're supposed to.
Understandable.
They're saying loudness is measured in decibels, and the formula for loudness of a sound is given by this formula, which it's not formatted well. It's not 2 variables here. It's just the output. You can think of it as d sub b is 10 times the logarithm of I divided by I0. And they say where I is the intensity of a threshold sound. So think of I0 as like kind of a standard sound, like something that you would normally hear. That's kind of normal to you. And then I is like something that's really loud, like a vacuum cleaner or an airplane or, anything you can think of that's really loud or soft potentially. Typically we think of it as being more or louder than this baseline sound. Maybe you remember in school when they're like, use your inside voice, use your outside voice, right? Like we have sort of standards that we've created.
Yeah.
Okay. Now they're telling you in this problem, they're telling you the value of I. They're saying I is 1.5 times 10 to the 12 power times this I0. and then it's divided by I0. So when you have an I0 on the top and the bottom, what can you do? If you have the same thing on the top and the bottom here.
And you would put the same 1.5 times 10 to the 12 on the bottom?
No, think of it as like X over X or 5 over 5. What do you do to those?
Hmm. Um, huh.
What is 5 divided by 5?
5 divided by 5 is 1.
Okay. How about X divided by X?
Wouldn't it also be 1?
Yes. So what is I0 divided by I0?
1.
Yes. They just cancel. So this becomes 10 times the log 1.5 times 10 to the 12. And
Okay.
this is your answer. Now your answer is going to be in decibels. So we're gonna get some number here and we're gonna put units of decibels right next to it.
Okay. Sorry, I'm a
You'll
little
have to go to that
tired.
calculator again. And yeah, I understand it's Friday. We're all ready for the weekend.
Yeah, I also had like a little bit of a rough night sleeping. It's okay
All
though.
right.
I'm doing good, so that's all that matters.
Mind over body. It's
Exactly.
only your mind that's thinking it was a rough night's sleep.
Yeah. Okay, so oops. So the answer would be 121.77.
Yeah, let's just round to the ones place, 122 decibels.
Okay. Okay.
That is and that's it. I mean, that's what it's asking for. How many decibels is it? And the answer is 122, and that's it.
Let's go. We did it.
Okay, so from here you have a review assignment which is not open as far as I can tell. Do you have any feedback from previous lessons that we need to look at? Or
No,
do you want
not
me to?
really. I don't think
Okay.
so because I can't. And if I try to check it, it's gonna take forever for me to get the.
Well, let me see if there's something I can do to check. Just because
Okay.
I guess that would help here be something good.
Yeah.
All right. Let me might need I'm gonna share another screen just because I'm not quite sure I know where to go here. Let me know when that loads up for you. There it is. Where do we go from here to sort of see how you're doing?
You go to so you go to full courses and lessons if you want to see the lessons and
Right. And what I'm saying is like we've turned you like this week you've turned in law of logarithms. You've turned in just open up
I,
the full course lessons
I
here.
have to submit the last 3 lessons, but I might have to do it like some other time because I right now do not have Wi-Fi.
Okay, so I see. So that's why it has not been great. But it looks like you're really in good shape here with these. You know, everything's kind of syncing up the way you want and looking really good here. So what we cannot obviously access this assignment until next week. We have some options, I guess. I can help you review some logarithm stuff.
Yeah, that
Um,
works with me.
all right, sounds good. Let's do that here. Let me go back to the other screen. Okay, so the most basic thing is if I give you something like 3 to the 5th equals 243, you have to be able to write that says log base 3, 243 equals 5. You have to see that all the numbers move around.
Mm.
Okay, and so like if I were to give you a problem like this and say log base 5 of 125 equals 3, could you tell me the exponent form? Like what goes up here to match what's here? Basically, I'm asking you to rewrite it kind of going backwards from this one on the right.
So it would be like, let me see. So it'd be like log base. Hold on, I'm just looking at what you wrote and what you want me. I'm just hold on. So it'd be log base of 125 with, and then it's 3, and then it equals 5. So I don't know if I worded it wrong, but
So I'm looking for the exponent form. So you're going to say like blank to blank equals blank. We're looking for a number equals number.
So it would be so it'd be, why is this so hard?
Try to follow one number at a time, like the base here, follow it back up.
Okay.
Some people like think of this like a candy cane or something, but it's the chutes and ladders game where you just sliding numbers around, moving things around.
So it would be 5 to the power of 3
Okay,
equals 125.
very good. Okay. So now you also have to be able to go the other direction, right? You have to be able to say, okay, if Matthew gives me the exponent form, the one on the top, you have to be able to write the log form. Okay, so let's do an example here. Let's say it's 2 to the 4th equals 16. There's a base, there's a thing you're taking the log of, and it equals something.
Okay, so the log would be the log would be 2. No, wait. Yeah. 2 to the 16th
Of 16, yep, good.
equals 4.
You got it.
Woohoo.
All right, so let's try another one here. So more generally, okay, if I give you something like this, log base b of x to the n, which equals a number m. So this is where it gets harder. It's like, I'm sorry, let me just do it this way without the n. So this is the more general one. We've been doing it with numbers, but it's like this. This becomes b to the m equals x. It's the same thing though.
Okay.
But you have to be comfortable moving back and forth between them. So this would be like the thing to write down if you were trying to wanted like a reference. Okay, so a few problems here to look at now. I'm going to snip in those law of logarithms again, although the main one we're going to use is that law 3. Let me snip this in. So this is kind of the main one to use, that is that the exponent goes out in front. All right. So here's an example here. What's log base 4 of 16? What does this equal? Okay, and to do a problem like this, you have to rewrite 16. You have to rewrite 16 as 4 to some power.
4 to the 2nd.
So this becomes log base 4 of 4 squared. So can you use this property at the top here, this law, and tell me what the result is?
Log base 4 of 4 squared equals 2 log base 4 like that.
Good,
Like
keep
to the
going.
power. Okay. what else do I have to, what else should I keep going with? Like, which law do I go to
Okay.
now?
There is, so it's not written, but if the log base b of b, if these are the same, this equals 1.
Okay.
So how could we use that here? What does log base 4 of 4 become?
It becomes like 2.4, like, okay, wait,
What I'm trying to show you on the right here is that these are the same. B means it
right?
could be any number, as
Okay,
long as they're the same. As long as the base is the same, you're taking the log of, this is always 1.
okay.
So what is just log base 4 of 4? What does that become?
Log base 4 of 4 becomes 2, 2 times 1?
It's just 1. That part that put the kind of this bracket under is just 1.
Got it.
I mean, if it were log base 5.1 of 5.1, it's still 1. As long as these are the same.
Got it.
Okay. Let's try another one here. Let's say it's log base 8 of 512. So first thing you have to do is rewrite 512 as 8 to some power.
Okay.
You're welcome to use a calculator to try to investigate that.
Okay, I'll try using Desmo Scientific for this one. Okay, 512. Do I have to wait? Should I write the 512 equals 8, or do I write the one with the log? Or do
Neither.
I
You're
do?
just figuring out like 8 to the 1, 8 to the 2, and so on until you figure it out. Unless you know, like some students memorize these, but you can just go to the calculator and it's okay. 8 to the 1, 8 squared, 8
8 cubed.
is 8 cubed. So this is log base 8 of 8 cubed. Could you simplify this just like we did in the previous problem I gave you?
Sure. Okay. So it would be, I have to simplify it, so wouldn't it be like the same thing, like 8 times 1, like the previous problem too?
Well, it is just like the previous problem, except it's different numbers, but it's the same process. So if you want, I can scroll up and show you the previous problem.
Yeah, can you?
Sure.
Thank you. So yeah, basically it would be like log base 8 to the 8 cubed. And then just, man, logs are confusing.
Let me bring the property law down again.
Sometimes I understand logs, sometimes I don't. Okay. Okay, so log 8 of 8 cubed equals equals 8, which is log to base 8 log base 8 and then cubed. Or did I mess that up?
What happens to this 3?
Oh, it goes in
Good.
front of the log.
Yes. Okay. Now, what can you do with log base 8 of 8? What's this thing on the right become?
Okay, this now becomes, so it's gonna be 3 times 8.
No,
No, sorry,
let's go
3
back.
times 1.
Yes. So what is the result? What is the final answer here?
The final answer is gonna be 3.
Yes, good. Okay, let's do one more. What questions do you have though before we do this? Because the process is the same. You're rewriting whatever I'm giving you with the same base sum power. 16 went to 4 because there was a 4 here. 512 went to 8 because there was an 8 here, which is the base. Okay,
Got it.
so let's try another one. Let's go log base 3 of 243.
Okay, 243. Okay, so for 243, we'll go, what power can get to 243 with the
You'll have to do a little bit of testing, go there and what's 3 to the 1, what's 3 to the 2, what's 3 to the 3. Go ahead and calculate until you find it. I wouldn't give you one that didn't work. That wouldn't be very fair.
Yeah. Okay, can you give me a number that would work for me find the power for 200 that for 243 that could work? Wait, sorry.
I recommend going to your calculator just like we've done in the last 2 problems, maybe 3, and just guessing until
Okay,
you find it. It won't
3
take
to
you that long.
3 to the 5th.
Yes, it is 3 to the 5th. There's something about self-discovery that's better than, say, me just giving you the answer, because it creates awareness of
Yeah.
like
I was
how
just
certain
asking
numbers
what
lead.
number I was just asking what number do you think will work, and then I can just keep testing with the same number instead of me going to different numbers, you know?
Sure. So from here, go ahead and simplify this and let me know what you come up with.
Okay. Mm. So the answer would be 5.
The answer is 5. Very good. All right. So let's take a look at the the first logarithm law. I'm going to snip it in here. Okay. This says that if I give you a product inside parentheses, that it becomes a sum of them. So if I, for example, wrote log base 2 of, and I'll just say 2 times 5, this becomes log base 2 of 2 plus log base 2 of 5. So notice that whatever's inside parentheses there, whatever we're multiplying becomes a sum. A single logarithm goes to 2 logarithms with each of these things inside. Is that clear?
Yeah,
What is log base 2 of 2? What does that become?
that becomes 4.
Nope.
Uh,
Log base b of b is 1. If the base is the same as the thing you're taking the log of, it becomes
oh,
just 1.
so sorry, log base 2 of 2 is 1 as well.
Yes. Yes. Very good. Okay, so let's use this property again. Okay, so let's say I give you something else. Let's say it's log base 3 of 9 times 4. this becomes log base 3, 9 plus log base 3, 4.
Got it.
Is there anything else that you can reduce here?
The 3 to the 9th, maybe?
Yes, yes, you can simplify this the way we were doing in earlier problems here. Will you attempt to do that, please?
Sure. It's 3 to the 9th. That's gonna
So
be.
it's not 3 to the 9th. It's you want 9 to become 3 to some power.
Oh, that'd be 3 to the 2nd. 3
I
squared.
agree. Yep, I agree. So keep going here. See if you can work this out.
Ugh. So now it's gonna be like log 3 in parentheses 2 times 4 equals log 3 to the 2nd power
Nope,
plus
nope.
log. And
So everything like what you're doing right here, this right here in red is exactly what we were doing starting here. I'm asking you to do a problem like this, or a
oh,
problem like this, or a problem like this.
oh,
Okay.
okay, sorry. So log 3, log 3 to the 2nd equals 9. Ugh. So that would make it. Hold on, I'm confusing myself. Give me like 1 second. Okay. So okay, so log 3 to the 3, so it's like log base of 3 squared basically
Yes, exactly. Yeah. Okay. So
equals
what does
so it
what?
equals 9, right?
No, no. I mean, what you said is correct. Okay. So
Okay.
what does that become? It's not 9. I mean the part.
Oh, okay, hold on. So then it would be 3 log base of 3 squared, and then it'd be like 2 times 1, so the answer would be 2.
Yes.
I did it.
Right. See if we can do one more here. Log base 5, 125 times 3. Okay, so this becomes log base 5, 125 plus log base 5 of 3. So that product becomes a sum. Take a look at this one here and see if you can simplify it, please.
Okay. Okay, so I just simplified the log base of 5 to the power of 125 to make it log base 5 base of 5 cubed.
Good.
Okay, now do you want to do the same as like the previous problem?
Yeah.
Okay, so then that's gonna be 5 log 5 3. So the answer would be 3.
Part is 3 plus log base 5 of 3. Good. All right, well done. We're going to go ahead and stop here for the day.
Thank you.
Yeah, you're welcome. Let me just stop the recording. All right, start video. Okay, so good job. We're all set for next week. I'll get back. I'll figure out schedule with your dad for next week. But looks like you're doing real well with your progress in this class, which is great. Looks like you'll be able to finish in the next 2 weeks here. So doing great. Thank you so much for letting me help you today. Hope you enjoy your time away, and I'll see you next week sometime.
Thank you. Have a good
You're
rest
welcome.
of
Bye
your
now.
day. Bye
Bye.
bye.